In this lesson, we are discussing still solving quadratic equations, but now including if there is a complex solution. So example one is a mixture of review, but also what we'll be doing in this lesson today. So like for example, 1a, 2 plus or minus the square root of 9. So if I wanted to simplify that, well, what is the square root of 9? Well, 3, right? So this represents 2 plus or minus 3, which now, if you recall, this is representing 2 plus 3 as well as 2 minus 3, right? That's what the plus minus represents. So really, the answer to 2 plus or minus the square root of 9 is 5 and negative 1. So that means how many solutions? Well, there are 2 real solutions. So in the past, we had simplified problems like this and got our 2 real. So then what is the square root of 0? Well, just 0, right? So this is 2 plus or minus 0. Well, 2 plus 0 is still 2, and 2 minus 0 is still 2. So with the square root of 0, this means we only have 1 real solution. So now here, the square root of negative 9. Well, this is 2 plus or minus 3i now, right? Because this is the square root of negative 9, which is the square root of 9 times the square root of negative 1. And the square root of negative 1 is I. So square root of 9 is 3, so 3i. So this is, with the plus and minus, 2 plus 3i and 2 minus 3i. So if you notice, it's like the conjugates, right? So now, how many solutions do we have here? Well, we have 2, but now imaginary, because these are now complex numbers. So here we're getting into focusing on 1 real, 2 real, or the 2 imaginary. So again, reviewing, we have solved these types of equations also in the past. So I also graphed this equation here in Desmos so that we could see and review. So like the parabola, for example, so here the parabola is represented by, I graphed x plus 3 to the second power. Then the line in blue that I graphed represents here, but this is, so when you graph it, this is y is equal to 4. So if you notice, how many solutions do these two graphs have? Well, they have 2 real because they cross at 2 points. So that means if we were to solve this, we should get 2 real solutions. So I take the square root, because here this was all grouped together now, x plus 3 to the second power. So now we have to take the square root to get rid of our exponent, inverse operation. So now x plus 3 is equal to plus or minus 2. So this is now, when we subtract 3, this is the same as, after breaking this apart, this is negative 3 plus 2 and negative 3 minus 2. So our 2 solutions are x is equal to negative 1 and negative 5. So if you notice here, they are crossing at negative 1 and at negative 5. So that's the 2 real, two real solutions. So now notice here, again, what are we going to do first? Well, we're going to take the square root, right? I'm going to take the square root because this is the inverse of raising to the second power. So x plus 3 is now equal to, but that's the square root of negative 4, which is now plus or minus 2i. So now here, I'm going to subtract 3 from both sides. And x is equal to negative 3 plus or minus 2i. Now, can we combine these? No, because this is a real value and 2i is imaginary. So this is the 2 solution, our 2 imaginary because they're complex numbers. So this represents -3 plus 2i and -3 minus 2i, like our two conjugates. So now we're going to start getting into not just two real solutions or one real, right? But two imaginary as well. So like here in 2a, notice again, we've got our parentheses all grouped together being raised to the second power. So we've got to get rid of that. So we're going to take the square root. So here I've got x plus 3 is equal to the square root of 121. Well, that's just plus or minus 11. So now here to solve for x, what are we going to do? Subtract 3, opposite operation, right? So now x is equal to -3 plus or minus 11. So now can we combine these? Yes, because they're both real. So we're going to have two real solutions. So remember, this represents -3 plus 11 and -3 minus 11. So here, one solution, real solution, x is equal to 8. And here, -14. So now let's go to the next. So again, here, what are we going to do first? Take the square root, right? Because here our parentheses all grouped together being raised to the second power. So square root. So now here we've got x plus 12 is equal to the square root of -25. Oh, so notice, right? This is the square root of -25, which is the same as the square root of 25 times the square root of -1. And the square root of -1 is I. So this is plus or minus 5i. So now notice we're going to end up with imaginary solutions. So now what are we going to do here to solve for x? Subtract 12 from both sides. And x is equal to -12 plus or minus 5i. So now here, can we combine them? No, because this is real and this is imaginary. So x is equal to these two complex solutions. So if you also want to see -12 plus 5i and -12 minus 5i. So 2c. Now notice here it just got switched, so it's all the same, right? But are the parentheses here grouped together but by themselves? No. Notice how it's being multiplied by 3. So what do we have to do first? Divide by 3, right? So inverse operation. So now here we've got -16, and that is equal to x minus 1 to the second power. Now our parentheses here grouped together, we can take the square root of both sides. So this is equal to, canceling out, x minus 1. Now what's the square root of -16? Plus or minus 4i, right? Because this is the square root of -16, which is the same as the square root of 16 times the square root of -1, which is I. So now what do we have to do here to solve for x? Add 1. So now here I'll just switch it. So x is equal to, that's a positive 1. So 1 plus or minus 4i. And again, can we combine these? No, because 1 is real, 4i is imaginary. So we have two imaginary solutions or two complex numbers for our solution. And again, if you want to practice writing it out, this would be 1 plus 4i as well as its conjugate, 1 minus 4i. So now for our next example, again, here's our parentheses all grouped together being raised to the second power. But is this by itself? Can we take the square root? No, because we're adding 4 to it. So what do we have to do first? Subtract the 4, right? We got to isolate. So inverse operation. We've got x minus 5 to the second power is now equal to 16. Now we can take the square root. And so now here, x minus 5 is equal to, well, the square root of 16. Well, that's just 4. So plus or minus 4, and then solve for x. Here, we're subtracting 5, add 5. And x is equal to positive, sorry about that. So positive 5 plus or minus 4. So now can we combine these two values together? Yes, because they're both real. So remember, this is the same as 5 plus 4 and 5 minus 4. So here, x is equal to 9 and 1. So 2 real solutions. So let's see, what do you think is the first step for our example here, our last one? And so here, that first step is to add 1. Think about it like a 2-step, right? So you should have noticed we're subtracting 1, but we're also multiplying by 3. So think of the 2-step, right? We always add or subtract first, then multiply or divide. So we're going to add the 1 here, so bring down 3 times x plus 6 to the second power, which is equal to negative 15. Now, divide by 3 because it's being multiplied, the parentheses. And here we've got x plus 6 to the second power is equal to negative 5. Now we can take the square root. And here we've got x plus 6 is equal to, now, this is the square root of negative 5, which is the same as the square root of 5 times the square root of negative 1. And the square root of negative 1 is I, so we do have a complex solution. However, can we simplify the square root of 5? No. So we're going to leave it plus or minus I radical 5. Then here, now we subtract 6 to solve for x. And here we've got x is equal to negative 6 because we subtracted, then plus or minus I radical 5. And this is our 2 imaginary solutions. So again, if you wanted to see how this looks, this is negative 6 plus I radical 5 and negative 6 minus I times radical 5. So that's the 2 complex solutions here. So now go ahead and pause the video and do the 3 U-tries on your own. So remember, the goal is you get the parentheses first, right, by itself before you take that square root. And if you have the 2 operations, make sure to follow like your 2-step. Always add or subtract first and multiply or divide. So go ahead and try these 3 U-tries and let's see what you get. And here we go. So here for the first one, you should have subtracted 1 first to isolate the parentheses. So x minus 2 squared is equal to negative 1. Then take the square root. So here I've got x minus 2 is equal to plus or minus just I. Or you're not wrong if you put 1i. So plus or minus I. Then add 2 to both sides to solve for x. And x is equal to positive 2, so 2 plus or minus I. That is your 2 imaginary solutions. So then here in 2b, you had to subtract the 100 first. Isolate the parentheses. X plus 1 squared is equal to 49. Then take the square root. And so now here, x plus 1 is equal to plus or minus this good old 7. It's a real solution. So you're going to end up with 2 real. Subtract 1 from both sides to solve for x. X is equal to negative 1 plus or minus 7, which represents, right, negative 1 plus 7, and negative 1 minus 7. So here, x is equal to 6 and negative 8. Then last, you had a 2-step here. So first, you needed to add 10 to both sides. Negative 3 times x plus 3 squared is equal to 30. Then divide, but divide by negative 3, because that's what's being multiplied. And x plus 3 squared is equal to negative 10. Now you can take the square root. and x plus 3 is equal to, you should have noticed, the square root of a negative 10. So I and just radical 10, because you can't simplify that radical. Oops, sorry about that, plus or minus I radical 10. Now solving for x, subtract 3 from both sides. And x is equal to, that's negative 3, then plus or minus I radical 10.